Let's continue with yesterday's lecture by putting some more emphasis on these filters. I told you yesterday that inductors and capacitors are the main building block of any filter. Now let's talk about the inductor. The property of the inductor is to oppose the change in the current. Alright, now what happens that when this current reaches a certain value or the average value, the energy is stored in this inductor. Okay, now this energy stored, it opposes this change here, this sudden change here, and you get the output something like this. Alright, it won't let it fall also beyond this level. So this is how an inductor works along with this principle which I told you yesterday. Let's discuss little more about the capacitor also. So this capacitor I am dealing with a half wave rectifier. Suppose this is your half wave rectifier. Okay, this is a half wave rectifier. You have a load here. Alright, and there's the transformer secondary and the half wave rectifier. This is what it is. This is load resistance RL. Now what happens, just see, when I apply a capacitor here, I am applying a capacitor of value C here. What happens that when this diode, when this is positive and this diode is forward biased, what will happen that this capacitor will get charged to certain value. Say this gets charged to the maximum value. Let me use another pen. Say this gets charged to some maximum value from this point to this point. It gets charged to the maximum value. Alright, once it has charged to a maximum value, what happens when this potential is more than this potential? Alright, suppose here it is, this is the maximum value. After this, say this is 15 volt at this point is 14 volt, it is 14 now. So this diode, it acts as a open circuit. Now when this acts as an open circuit, this charge, it gets discharged through this load, then it will get discharge up to certain point. Let's assume this is a straight line. Okay, now further again this becomes forward bias and it charges to maximum value and further it discharges. So let's read this way. Okay, so you will get a triangular wave at the output if you apply a CRO here. If you apply a CRO at this point, you will get a triangular wave. Alright, so this is what happens with in case of a capacitor. Is clear? Now suppose I say that this time from this point to this point, suppose I say that this is the charging time. Alright, where the capacitor gets charged. Suppose I say that this time is suppose T1. Okay, and this is the discharging time. Suppose I say that this time, discharging time is suppose T2. If you see in this case, the diode is conducting in this region. If you see this diode, it is conducting in this region. Let me use another pen. This diode, it is conducting in this region. Here also, this is suppose this is your charging time and this is discharging time. This is the time in which your diode is conducting. This diode is conducting in this region. Alright, on the other hand, if the capacitor was not there, this was your waveform, it was conducting this complete region here. Alright, now the idea is that if I can reduce this width, this will become more and more flat. This is the basic idea of using a capacitor. And one more thing, as I told you that I haven't done the derivation with you, how much will it get charged? If you see, if the repulse voltage is this much, the amount of voltage charged, how much? It is equal to Q is equal to CV. So it is C into ripple voltage VR. And charge stored will be equal to the charge discharged. So how much charge will be discharged? Can I say it is equal to IDC into T2. With the help of this, you can derive the formula which I told you yesterday. Alright, although this is not part of your syllabus. So this is the basic idea about the capacitors and filters that you use along with XL and XC. Let's deal with a very simple examples of filters. Okay, I'm taking few examples, very simple example. Let's take one numerical problem here. It says that calculate the value of capacitance used in a capacitor filter connected to a full wave rectifier at a standard aircraft of frequency 350 Hertz. What is this given to you? This is the frequency. Alright, this frequency given to you. power supply of frequency itna if the ripple factor is 10%. This is ripple factor gamma is how much? 10%. Can I say it is 0.1? Okay. And a load resistance, this RL, this is nothing but simply it is not RL, it is like this. Load resistance is 450. Okay, what you have to do, you have to find the value of capacitance, you have to find the value of C. So I told you yesterday in the last lecture that for a full wave rectifier, alright, this is given by, for a full wave rectifier, this ripple factor, this gamma is given by 1 upon 4 root 3 FC into RL. Everything is given to you. This is 0.1. Substitute this value as 0.1 here, 4 root 3. The value of F is given to you how much? It is 350 and RL is 450. If you calculate from here, you will directly get the value of this capacitor C is 91.7 microfarad. Please do this calculation on your own. Okay, it's a very simple numerical. Let's take one more numerical, which is mainly based on your LC filter effect. Very simple numericals, very basic ones. It says a full wave rectifier uses LC filter. Remember this type of LC filter where you have this L and C here prior to this load RL, which I discussed with you yesterday, and there's a rectifier here. Alright, LC filter having value of L is equal to 20 Henry and this is C. This C, value of C is given to you how much? It is 15 microfarad, or I can say it is 15 into 10 to the power minus 6 farad. The applied voltage V is 300, see this 300, it is 300 sine 100 pi t. If I compare this is equal to Vm sine 2 pi ft, it will be 2 into 50 into pi ft. So from here you can say that the value of f will be how much? It is 50. It is clear, and it has been asked to find the ripple factor. This gamma you have to calculate from here. I told you the formula yesterday for this LC filter, if you remember. It is equal to, this is given by 1 upon, see, 6 root 2 omega square LC. 1 upon 6 root 2 omega square LC. Substitute the value of omega is equal to 2 pi, or it is omega t. 2 pi f is 50. You can find the value of omega and find out all this. Do all these calculations here. Everything is given to you. You'll find that this ripple factor is equal to 0.398%. Alright, I'll stop it here. In the next lecture, we'll start with regulators.